Welcome to myprojectbazaar.com. Now we are going to discuss about the product automated diagnosis of normal and alcoholic EEG signals. Now we are going to discuss about the abstract for the process. Electroencephalogram, that is the EEG, is a recording of an electrical activity of the brain from the brain waves produced by the electrical current passing through the nerves during the brain activity. The nonlinear features are extracted from the EEG signals such as approximate entropy, that is the APEN, largest Lyapunov exponent, that is the LLE, sample entropy, that is the SAMPEN, and the four other features are high order spectra, that is the HOS features. Finally, fuzzy neural networks, that is the FO1, is used for classifying the EEG signals as normal or alcoholic. Based on the fuzzy neural network can analyze the performance in terms of the accuracy and sensitivity specificity. Hence, this process is well applicable for the deduction of whether the person is normal or alcoholic by using the signals. The process is only applicable in the datasets by using the fuzzy neural network classification, and hence the performance is majorly justified by using the accuracy, sensitivity and specificity, whether the process is efficient or not. Now we are going to discuss about the flow diagram for the process. At first, the input signal is taken from the dataset. The dataset is the folder which consists of the several input signals. After getting the input signal from the dataset, the pre-processing is carried out. The pre-processing consists of two steps. First one is the digital low-pass filtering, then the second one is the digital high-pass filtering. By applying these two filters, the signal is free from the noise. Hence, the noise-free signal comes out from the pre-processing module. After the pre-processing steps, the feature extraction is carried out. The feature is extracted from the signal by using these four type of feature extraction method. The first one is the LLE, then the second one is the APEN, then the third one is the SAMPEN, then the fourth one is the HOS. By using these four parameters, we can extract the corresponding data from the signal, and hence these data are considered as a test feature. After collecting test feature from the input signal, the classification is done. For the classification, we have to give three inputs. First one is the test feature, then train feature, then the last target. The test feature represents the feature of the input signal, then the train feature represents the feature of the whole dataset signals, then the target represents the two types. The first one is the normal, then the second one is the alcoholic. So here we have the two type of targets. Then after the classification result will be displayed as an normal or alcoholic. After the classification, the performance is estimated. Hence, the process is more reliable and efficient by using the classification and the efficient feature extraction. Now we discuss the initial running procedure for the process. At first, open the MATLAB 2013 and change the current directory. If you want to execute the code, means just right click in the main.m file and select the option run. Now the dataset folder was opened. In that you can see the 10 samples of signals. Select any one signal from the dataset. After the selection of the signal from the dataset, click the button open. After clicking the button open, the process will done automatically. Now the signal which I have selected is processed according to the module wise. First input, pre-process, feature extraction, then classification. Now the process will be done. Now we are going to discuss the result one by one. This is the input signal which I have selected. The input signal is plotted in the figure 1 with the title input signal. After the getting input signal from the dataset, the pre-processing is carried out by the two steps. First one is the digital low pass filtering, and then the second one is the digital high pass filtering. By applying the low pass filtering, the low pass filter is applied and then the noise removed filter sample is shown in the figure 2. Now in this figure, the high pass filter is applied and the noise free signal is plotted in the figure 3. After the pre-processing step, the feature extraction is carried out. Here the first LLE feature is extracted and then the values are plotted in the tabulation. Then the approximation entropy, that is the APN value, is extracted from the signal and those values are plotted in the tabulation. There are nearly hundreds of features are there. After the sample entropy features are extracted and then those values are plotted in the graph format, hence this feature is well optimized and then plotted in the graph format. Hence the normalized bispectral entropy is extracted from the signal and those values are plotted in the tabulations. After that, the normalized bispectral entropy squared is applied. Then the bispectrum phase entropy is extracted and then the value are plotted in the graph. Then the mean for the bispectrum magnitude is applied and then those values are tabulated. Then the test feature is collected by concatenating these three features extracted from the before feature extractions. After the test feature extraction, the classification is done by using the neural network classification. Hence the signal is normal means the message box will be displayed as normal person. After the message box display, the accuracy, sensitivity, specificity, then precision, recall, F-score values are calculated and then these values are shown in the command window. Thanks for watching this video.